In physics and engineering, in particular fluid dynamics and hydrometry, the volumetric flow rate is the volume of fluid which passes per unit time, usually represented by the symbol Q. The SI unit is cubic meter per second. Another unit used is SCCM. In US customer units and British imperial units, volumetric flow rate is often expressed as feet 3 per second or gallons per minute. Volumetric flow rate should not be confused with volumetric flux, as defined by Darcy's law and represented by the symbol Q, with units of m3, that is, ms-1. The integration of a flux over an area gives the volumetric flow rate. Fundamental definition. Volumetric flow rate is defined by the limit, i.e., the flow of volume of fluid V through a surface per unit time t. Since this is only the time derivative of volume, a scalar quantity, the volumetric flow rate is also a scalar quantity. The change in volume is the amount that flows after crossing the boundary for some time duration, not simply the initial amount of volume at the boundary minus the final amount at the boundary, since the change in volume flowing through the area would be zero for steady flow. Useful definition. Volumetric flow rate can also be defined by where equals flow velocity equals cross-sectional vector area, surface. The above equation is only true for flat, plane cross-sections. In general, including curved surfaces, the equation becomes a surface integral. This is the definition used in practice. The area required to calculate the volumetric flow rate is real or imaginary, flat or curved, either as a cross-sectional area or a surface. The vector area is a combination of the magnitude of the area through which the volume passes through, A, and a unit vector normal to the area. The relation is. The reason for the dot product is as follows. The only volume flowing through the cross-section is the amount normal to the area, i.e., parallel to the unit normal. This amount is where theta is the angle between the unit normal and the velocity vector v of the substance elements. The amount passing through the cross-section is reduced by the factor. As theta increases, less volume passes through. Substance which passes tangential to the area, that is perpendicular to the unit normal, does not pass through the area. This occurs when theta equals pi 2, and so this amount of the volumetric flow rate is zero. These results are equivalent to the dot product between velocity and the normal direction to the area. When the mass flow rate is known, and the density can be assumed constant, this is an easy way to get where equals mass flow rate equals density. Related quantities. In internal combustion engines, the time-area integral is considered over the range of valve opening. The time-lift integral is given by where is time per revolution, is distance from camshaft centerline to cam tip, is radius of camshaft, is the angle where opening begins, and is where valve closes. This has to be factored by the width of the valve throat. The answer is usually related to the cylinder swept volume.